Good afternoon, ladies and gentlemen. Welcome to another trip into your Module 4 book. We are going to pick up with exercise number 2 on page 94. So grab your page 94, grab something to write with. Okay. You may also want to have a calculator. As you saw in the last couple of videos, I had to kind of scramble to get a calculator. I'm trying to think ahead this time. Okay. So I got a calculator to do a little bit of calculations to make my life a little bit easier and hopefully make yours a little easier as well. Okay, so we're going to pick up on question 2. Okay, so we went through question 1 already. The way we go through question 2 is going to be very, very similar. All right, the difference isn't going to be much more other than just simply using different numbers because we have, in this case, a different situation. Okay, so Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. So in 45 minutes, she was able to go 20 miles. And so for part A, they asked for what fraction represents her constant speed. Again, speed is distance divided by time. So we need to use and continue to use that same formula. Okay? It's distance divided by time. So in this case, her distance is 20 and her time is 45 minutes. And so this is the fraction that we are going to use to represent her constant speed. We're going to use this proportion. We're going to use this ratio between distance and time to essentially finish the rest of the problem and answer the questions and kind of extrapolate that data outward. So let's take a look at part B. Part B says, what fraction represents constant speed, C, if it takes her X number of minutes to get halfway to her friend's house? All right, so she lives 20 miles away from her friend. So halfway, we're looking at a distance of 10. So we need to think, if we're using that same constant speed, we need to use that same proportion. So if we need to figure out how far it takes her to get 10 miles, all right, time is what we're looking for. So our fraction here is 10 over x. We know she needs to go 10 miles, which is halfway, but we don't know how long that's going to take. So that's what we need to figure out. Part C, this is where we take part A and we take part B, both equations, and set them equal to each other. Okay? So we said that 20 over 45 was equal to C, her constant speed, and we also said that C is equal to 10 over x. Both of those things are equal to C, which means both of those things can be equal to each other. So we're going to take both of these fractions, 20 over 45, and we're going to set them equal to each other of 10 over x. What we need to do now is we need to solve to figure out how many minutes it takes Stephanie to get to the halfway point from her house while moving at this constant speed. So to do this, we just need to cross multiply and solve. So we're going to cross multiply and do 45 times 10, which is 450. And then we're going to do 20 times x, which is 20x. From there, we have just a one-step equation. We're going to divide both sides by 20. And so x is going to be equal to, quick calculation, 450 divided by 20 is 22.5. So what that means is it takes her 22.5 minutes, so 22 and a half minutes, 22 minutes, 30 seconds, to get to the halfway point between her house and her friend's house. And that should make sense. 22 and a half is half of 45. So half of 20 would be 10, so half of 45 would be 22 and a half. Okay? So now what they want you to do with part D. Part D is kind of where the rubber meets the road here. So we figured out, cool, it takes her 22 and a half minutes to get to halfway. Great. Now, how long would it take her to get, would it take in 30 minutes? Or how long would it take her to get into 15 miles? And so what we need to do now is to create an equation that we could plug either an x variable or a y variable into to then find and answer one of these two things. Okay, so here we solved for an x. We could also solve for a y variable in terms of distance with our equation. And the way we create our equation is very, very similar to the other equations that we've done so far and the things that we did last year in 7th grade. Last year we used y equals kx as kind of our basis, as the equation. Okay, every time I said, when it says create an equation, this is the equation they're telling you to use. The same thing is true here. This is the equation that they're telling you to use. They want you to use y equals kx. But in this case, that k is your constant. That k is your constant proportionality here, your constant speed. We're also going to see it as your slope, which would be m, or your unit rate. So, in order to create this equation, we need to take y equals, and then our distance and time, our speed, our constant velocity there, which is going to then have us create an equation of y equals 20 over 45x. Now 20 over 45x, that can be a little bit cumbersome, so we're going to reduce this down to y equals 4 over 9x. Okay? So, that is going to be our equation to figure out how many miles Stephanie can go over any time interval. Any time interval. Okay? So, if we wanted to plug in a time interval, okay, so if we wanted to say, like, in 10 minutes, how far would she go? Well, we would take the minutes and plug it in to our equation, and then we would do 4/9 times 10. 4/9 times 10 is 40 divided by 9. So it's somewhere over a little bit over 4 miles. Okay, so you would get 36, which is 4, and then have 4 remaining, so 4 and 4/9 miles traveled in 10 minutes. Okay, you could do the same thing and plug in a value for y. If you want to figure out, again, how long it took her to go 15 miles, you would then just simply solve for x. So that is question number 2. And a lot of this, it's done the exact same way. We use y, we use x, we plug a number in, we get our equation. That's it. It's really simple to put together. It's really simple to make work. I also want to do question number 3, just so that way we're clear on what happens when we also have a y-intercept. Okay, so in our notes we talked about not just linear equations and y equals kx, y equals mx, but now we have a y-intercept also attached to this equation. Okay, so the way this works is we have to take our value, take our equation y equals 50x plus 15, and then give you an example here. You plug in 1 for x, and then you solve for y. We're going to do the same thing with question number 2. We're going to take the same equation and plug it in with 2 in there. So 50 times 2, that's 100. 100 plus 15, so that means y equals 115. Same thing for question number 3. Y equals 50 times 3 plus 15. 50 times 3 is 150 plus 15. So then y is equal to 165. The next one, 3.5. This is where things get a little bit tricky. This is where calculators really come in handy. We're going to plug in 3.5 the exact same way we plugged in our whole values. So we're going to do 50 times 3.5, which is 175 plus 15, which gives us 190. And then finally the last one. This one's going to be ornery. 4.1 times 50 gives us 205 plus 15 gives us 220. So let's show our work here. 205 plus 15 equals 220. And so what that means, using this equation, over the course of 4.1 hours, in this case, Dave would drive 220 miles. So we use the equation, plug in values for it, and then solve for the other variable that we don't have. All right? Good luck. Email me if you have any questions.